For this video, we're going to be discussing solving systems of equations by graphing. So what's a system of equations? A system of equations is just a set of two or more equations containing the same variables. And I'll tell you that we are only going to be worrying about two equations for this unit. And we're going to be working with two variables. So a system is just two equations having the same variables. Like, for example, down here, x plus y equals 8 and 2x plus 3y equals 22. These are two equations with the same variables x and y. The solutions to the variables have to make both equations true, meaning x plus y must equal 8 and 2 times x plus 3 times y has to equal 22. So for example, if I look here, if I say x is 2 and y equals 6, well, 2 plus 6 equals 8. Okay, that works. 2 times 2, that's 4. And 3 times 6, that's 18. 4 plus 18, that equals 22. So the solution to 6 works for both of these. It works for this equation here, and it works for this equation here. So that means this is the solution to this system. Right? In fact, this is the only ordered pair that works for this solution. We're going to discuss in a minute that there are 3 different types of solutions that they can have. This one only has one. So the idea is a system of equations, two or more equations having the same variables. The solution must be a solution to both of them. So for this video, we're going to talk about solving them by graphing. So we can solve our system of equations by graphing. Here I have two equations. I have 2x plus 2y equals 6, and I've graphed it. And I have 4x minus 6y equals 12, which is graphed here in blue. If we graph them both on the same coordinate plane, then the point where they intersect, right here, 3, 0, that is the solution to the system because it is a solution for both equations. It's a point that's on both lines. If I test it out, 2 times 3 plus 2 times 0, does that equal 6? Well, 2 times 3 is 6, 2 times 0 is 0, 6 plus 0 equals 6, 6 equals 6. So we know 3, 0 is an equation to that, or a solution to that equation. Then down here, 4 times 3 minus 6 times 0 equals 12. Well, that's 12 minus 0 equals 12. And that's 12 equals 12. So this point is also a solution to the blue line. So what we're saying is, the solution to a system can also be thought of as the point where the lines cross. So if we graph our equations and see where they cross, well, hey, guess what? That's going to be our one and only solution. So there are 3 different types of solutions that a system of equations can have. It can have one, infinitely many solutions, or it can have no solution. So we're going to discuss what each one of these looks like. Lines with a system of equations that have no solution produce parallel lines, lines that never cross. If we think of the solution being, hey, the point where they cross, then obviously lines that never cross have no solution. All right? Now remember, if we think back to when we talked about graphing, parallel lines have the same slope, but different y-intercepts. Okay, that's how we're going to know that two lines are parallel. So here's an example of two equations that are parallel lines. Y equals 2x plus 4 and y equals 2x plus 5. All right, they have the same slope, but they have different y-intercepts. That tells us that they're parallel, and they're never going to cross, so they're never going to have the same solution. We could also think of it if we set them equal to each other. 2x plus 4 equals 2x plus 5. Well, the 2x's can cancel out. 4 never equals 5, so there's no way these can have a solution. So, infinitely many zero solutions to this. Parallel lines produce no solutions. Lines that have, now I'm going to move on to lines, instead of doing one, I'll come back to that. Talk about lines that have infinitely many solutions. Infinitely many solutions are lines that are the exact same line. They're equations that produce the exact same line. For example, where'd my equations go? There were some equations hiding under there. There they are. These two equations right here. 3x plus 2y equals 10 and 6x plus 4y equals 20. All right, now they don't look initially like they're the same equation. However, if you notice, 3 times 2 equals 6, 2 times 2 equals 4, and 10 times 2 equals 20. If I divide this entire equation by 2, I get 3x plus 2y equals 20, meaning these are the same equation. The other way we could do it is we could put these into slope-intercept form. I get 2y equals negative 3x plus 10. So y equals negative 3 halves x plus 5. Similarly, 4y equals negative 6x plus 20. Divide by 4, and I also get y equals negative 3 halves x plus 5. So you notice if we put them in take them from standard form to slope-intercept, they're the exact same equation. So if they're the exact same equation, obviously they're the same line, and they have infinitely many solutions. No matter what I put in for x or y, it works for both of these. So the final result is for them to have one solution. And this is any time that they are either not parallel or not the same line, then they have exactly one solution. So that's how we can tell how many solutions there are. If they're parallel, so same slope, different intercepts, then they have no solution. If they're the exact same line, meaning one of these is a multiple of the other, or if we put them in slope-intercept form, they're the same line, then they have infinitely many solutions. And finally, if they have exactly one solution, it means they are not parallel, and they are not the same, then they have exactly one solution. These are our three options. So let's do some examples. All right, well, here let's talk about the procedure first. The procedure is simple. We're going to put both equations into slope-intercept form. Makes it easy to graph. We're going to graph both equations on the same coordinate plane, and then we're going to plot the point of intersection. If there isn't a point of intersection, then there's no solution. If both lines end up being right on top of each other, then it's infinitely many solutions. And if there's only one point, then it's going to be that one solution. So let's give these a try. Example 1 says, solve the system of equations by graphing. 2x plus y equals 4, and 3x minus 2y equals 6. So we need to start by putting these in slope-intercept form. So 2x plus y equals 4. Simply subtract 2x on both sides, and I get 2x plus 4y, or y equals negative 2x plus 4. Similarly, I have y equal 3x minus 2y equals 6. Subtract 3x from both sides, I get negative 2y equals negative 3x plus 6. Divide by negative 2, and I get y equals 3 halves x minus 3. So now what I'm going to do is I'm going to graph both of these equations. So I'm going to start by graphing my blue equation, my top equation here. I know my y-intercept. My y-intercept is 0, 4. So 0, 4. Plot that point. And then my slope is negative 2, which I'm going to think of as negative 2 over 1, which means down 2, right 1. Down 2, 1, 2, right 1. There's another point. Now that I have 2 points, I'm going to draw my line. So my line needs to go through both points. All right, I'm going to make it extra long here. Okay, now I'm going to do the same thing for the red equation. I know my y-intercept is at 0, negative 3. And I know that my slope is 3 over 2, which means 3 up, 2 right. So I'm going to go up 3. That's 1, 2, 3. Puts me at 0. 2 right puts me right here. You can already see what the answer is going to be for this one. Now I'm going to graph that equation by connecting those 2 points. And we see that our lines cross right at this point here, meaning there is exactly one solution to this system of equations, and that solution is this point, which is 2, 0. All right, so that is the solution. Now we can check it by going back up here. 2x plus y equals 4. That's saying 2 times 2 plus 0, if I plug in my x and y, equals 4. 2 times 2, that's 4, plus 0. 4 plus 0 is 4, so I get 4 equals 4. Good, it works for that one. And then let's try it in 3x minus 2y equals 6. 3 times 2 minus 2 times 0 equals 6. Well, that's 6 minus 0. 6 minus 0 is 6, so I get 6 equals 6. Works for that one. So my answer is 2, 0. It is just this point here where they intersect. So that's all we have to do to solve these by graphing, is graph them both on the same coordinate plane and find the spot where they cross. Let's try one more example. Example 2 says, solve the system of equations by graphing. All right, so my first step, put them both in slope-intercept form. Start with my green equation here. Or put it in blue. 5x plus 3y equals 15. Going to subtract 5x from both sides and then divide by 3. I get y equals negative 5/3 x plus 5. Now let's work on the bottom equation. Going to start. I've got negative 25x minus 15y equals 60. Going to add 25x to both sides. I get negative 5y equals 25x plus 60. Divide both sides by negative 15. Got to remember that 25 over 15 reduces, or it's 25 over negative 15, reduces to, well, they're both divisible by 5. 5 over 3, and it's negative. So I get negative 5/3 x plus 4. So now if I graph these, well, we can tell right now before we even graph. Slopes are the same, negative 5/3, negative 5/3. The y-intercepts, however, are 5 and 4. They're different. And I tell you right now, these are parallel lines. They are never going to cross. So there will be no solution. But let's just show that for a fact. I'm going to start by going up to my y-intercept, which is 5. My slope is negative 5 over 3, which means down 5, right 3. So down 5, 1, 2, 3, 4, 5, right 3, 1, 2, 3. Okay, there's our second point. Let's draw our line, connecting these 2 points. All right, close enough. Okay, similarly with our other one, y equals negative 5/3 x plus 4. Well, okay, I said close enough, but I was kind of wrong. It wasn't really close enough. Let's try this one more time. Let's make this line a little better. There you go. That's a little better. All right, so we know that our y-intercept is right here at 4. And then I'm going to go down 5. That puts me at negative 1. Over 3. Puts me at 3 here. So now these lines are going to be very, very close together. However, you should be able to tell that they're never going to cross. They're just going to run very close together on and on and on forever. They're parallel lines. So the answer to this problem is that there is no solution. There is no point on the blue line that is also on the red line. So there is no solution to this system of equations. All right, let's try one final example. We're going to solve this system by graphing. Now this one's kind of nice because my first equation here on top, y equals 4x plus 2, well, that's already in slope-intercept form, so I don't really have to do anything about it. The second one I need to put in slope-intercept form. I get negative 20x minus 5y equals 10. Add 20x to both sides. Now I'm going to divide by negative 5. Oh, got a problem here. This should be... Now you're going to see how Mr. Harrington comes up with problems and how he can sometimes mess them up. This should be a minus 10. Okay, which makes this, if I divide by negative 5, makes this negative 4x plus 2. No, positive 4x plus 2. Man, I am off on this one today. So positive 4x plus 2. So what do we notice about these two equations? What we should notice is that they are the exact same thing, which means if I plot them, 4x plus 2, well, that means I start at 0, 2, and I go up 4, right 2. Okay, here's going to be my first line between these 2 points. And then my second line, well, it's the exact same thing. So my second line is going to look the exact same. It's right on top of the other one. Okay, because they're the exact same equation, they're the same line, which means that the answer is infinitely many solutions. Okay, or the other way of writing it, all real numbers. Because any number that I put in for x or y will be a solution to this system. Because they're the exact same equation, we have infinitely many answers. The answers are all real numbers. All right. So, your try it problem for tonight is to solve this system by graphing.